Hey guys, welcome back to the channel. Today we're going to be solving LeetCode 338, counting bits. Okay, it's an easy problem, but to be honest, it was kind of tricky for me to kind of figure out how to solve it. But it says it's easy, so we're just going to go with whatever they say. Okay, so feel free to pause the video just to read through what the problem is asking, but I find the examples more descriptive. Okay, so given n equals 2, so we want to create an array of 2, okay, of 0 to 0 index 1 2, where each element in the array is the number of ones in the binary implementation of that. So again, 0 in binary is just 0 0 0, right? There's no 1 in there. 1 is just 0 0 1, right? In binary there's 1 1 in there. 2 is just 0 1 0, okay? There's 1 in there, so it's just a number of ones in there. Okay, so first I'm not gonna go through this, but again, 0 there's none, 3 there's 2, 4 there's 1, 5 is this. Okay, so there's a straightforward way to do it. This is using a built-in Python function from the collections module called counter. So first I'll create a variable called result, set them equal to an empty matrix. Okay, then I'm gonna iterate for I in range what range n plus 1, and I'm doing n plus 1 because the range operator is exclusive of the upper bound. So this is just going to go from 0 to n. It's not going to go to n plus 1 because it's exclusive of the upper bound. Okay, so this, what I want to append to result. So I say result dot append. Now what do I want to append? Okay, I want to use the counter. This is a method provided by the collections module of Python. Okay, binary. Okay, and so I'm converting n to binary. That's what this bin n is doing. Okay, converting him to binary. Then I want to count him. So what counter does is it returns a dictionary key value pairs of each element of whatever string you pass to him or whatever list you pass to him and their number of occurrence. So the key is the element, the value is the number of times they occur. So I want the number of times one occurs. Okay, so once I do this for the for loop is done, I can just return my result. Okay, so let's go ahead and submit this and see what's up. Let's see what's going on. Let's see what's cooking. Okay, okay, so it gives us an error. This is correct, but it gives us an error. It says built-in method. We're not allowed to use a built-in method. Let me make sure that's why. Okay, yeah, I believe that's why we're not allowed to use in a built-in method like we're using the collection. So let's think of a different way to do it. Okay, yeah, I've taken the liberty to write out some things for us. Okay, I wrote out the numbers from 1 to 15 and its binary representation. So let's go in and manually count the number of ones in there. So for 0, there's obviously 0 1 in there. For 1, there's 1 1 in there. For 2, there's 1. For 3, there's 2 ones. For 4, there's 1. For 5, we're just manually counting and there's 2. 6, there's 2. 7, there's 3. 8, there's 1. 9, there's 2. 10, there's 2. 11, there's 3. 4, there's 12, there's 2. 13, there's 3. 14, there's 3. 15, there's 4. Okay, do we see a pattern? Can we see a pattern in this? Okay, so let's look for a pattern. Okay, so I'm gonna call this first guy, he's our base case. Okay, let's see. Again, let's forget about these numbers we just wrote down. Let's forget about all these guys for now. Let's see if we can see a pattern that actually derive him. Okay, so this guy's our base case. When is 0, obviously I'm going to call this A, right? I'm going to call this case A, and obviously A equals 0. Okay, he's our base case. We know that 0 has 0 1. So now for the next guy, this guy, I'm going to call him B. And can we see that? Okay, I'm going to draw a line here actually for A. Okay, can we see that B is just equal to A plus 1? Okay, A plus 1, and since A is 0, which equals 0 for A, plus 1, so B is just 1, right? 1. Okay, kind of like we expected. Okay, I'm going to also draw a line at B. That's a terrible line. I'm going to undo it first and redraw it. Okay, I'm going to redraw a line. Okay, we have B. So now let's find C. So what is C? C is just going to be, I'm going to call this 2C. C, and C is just equal to the cumulative list of A and B. Okay, a list including A and B plus 1. Okay, so in this case, what does that mean? It means here this first guy is going to be a plus 1, and what is a? A is 0 plus 1. He's going to be 1. Okay, this second guy is going to be b plus 1. Where is b? B is 1. 1 plus 1 is going to be 2. Okay, can you see how it's matching now? Okay, now we have 1 and we have 1, and it matches the guy we counted. Okay, now let's draw a line across C. Okay, now next is D. Okay, what is D gonna be? D is gonna be cumulative A, B, C plus 1. Okay, so now let's start with A. A was 0. Okay, I hope this is making sense, but anyways, let's go. A was 0, right? 0 plus 1 is 1. Okay, next is B. B was 1. 1 plus 1 is 2. Next is C. C is this next two guys, right? There's 2 elements in C. C is 1. The first guy I see is 1 plus 1 is 2. Second guy is 2 plus 1, which is this guy plus 1, 3. Okay, let's draw a line here. Now all these guys are D. Do you see the pattern now? Okay, let's create E. E is going to be obviously equal to A, B, C, D cumulative plus 1. Again, let's start with A and see how it's all matching. Again, back to E. So A was 0. Okay, 0, you see A was 0. 0 plus 1 is 1. Okay, B was 1. 1 plus 1 is 2. C was 1. Well, there's 2 elements in C, right? The first guy is 1. So add 1 to him, he'll be 2. The second guy is 2, right? Add 2 to him, he's 3. Now D is the next 4 guys. Okay, so D, just take each element in D and just add 1 to them. So just 2, 3, again 3. So we're here 2 plus 1 is 3. Now we're here 3 plus 1, 4. So do you see how it all matches, right? This is E. Okay, so pretty much this formula holds. Okay, you can create the next guy. You can create B from A by just adding 1 to A. You can create C by adding 1 to A and B. You can create D by adding 1 to A, B, C, D. You can create E by adding 1 to A, B, C, D. Okay, so now that we've figured out the formula, let's go ahead and see what the code looks like. Again, this is correct, but it just gave us an error because we used a Python package. We're not allowed to use, like if you look at the bottom, it says, can you do it without using any built-in functions? Okay, so now let's code what we just explained. Okay, we're gonna create a result variable, kind of like we did before, a list, not an empty list, and we know the base case. The base case is 0, right? We established it. We said A is the base case, is 0. Okay, then let's build up from that base case. Okay, so we're gonna say while, okay, while the length of result, okay, right now result has only 1 element, but while the length of result is less than or equal to n is the number we're given, whatever number, because the problem asks us to go up to that number. Okay, while he's less than or equal to him, let's do some stuff. What do we want to do? We want to do result dot extend, not append in this case, extend. Yeah, separate spelling. Dot extend, not append but extend. What do we want to extend? We want to extend that list by a list which is just I plus 1. Remember, whatever was previously in the result, I, we want to extend him by I plus 1. Okay, now this is called the list comprehension for I in result. It's saying for each element in results, go ahead and append addition of 1 to that element back to him. So we're extending results by this. Okay, and then once we're done with the while loop, we just want to return results. Okay, let's go ahead and run the code and just kind of like a sanity check, just to see what's going on. It says our answer is wrong. Okay, why is our answer wrong? Okay, I'm sorry. Okay, we want to return results. Okay, but we don't want to return result by itself. Okay, we want to return everything in results. Okay, up to n plus 1. Okay, because he's gonna keep going. Okay, we want to you see how we have a 2 in here? We don't care about the last one. We just want to stop right here. Okay, now let's try that again. Okay, accepted. Let's go ahead and submit it. Bam. So 97%. As far as speed goes, we're awesome, and space is not too bad. But yeah, that's it for the video. I hope it was helpful, and I'll see you guys in the next one.